My name is Noah Lockwood, and this is Caleb Crewer, and this is our MET220 project.
So our goals for this project were to compare the efficiency between normally charging your phone with a plug-in wire versus charging it wirelessly. And so to do this with both methods, we're going to find the total energy transferred to the battery, and then we're going to divide that by the total energy into the system. Okay, so this is our test setup to determine the amount of power and with that also the amount of energy input into a phone by plugging it in directly with a wire. So you can see we have 2 meters hooked up here. One is going to be measuring voltage, this one. This one is going to be measuring the current. And so what we've done is we have our power block plugged in to a 120 volt socket. This converts that into direct current, and then where we're actually measuring from is the voltage into the wire, the voltage and current coming from this block and through the wire. And so you can see I have spliced this wire and we are currently measuring almost 5 volts and no current. That's because we don't have a phone plugged in. So when we plug the phone in, we should see that current meter go up, and it's just leveling out there. But by doing this, we can measure our current and voltage every 15 minutes. And by doing this, we're going to get an average current and voltage input into the phone and then multiply that by our time to get our energy required to charge the phone. So here we have a very similar setup for the wireless connection. You can see our block here plugged into our 120 volt socket that converts to direct current and voltage running through. This is where we're picking up our measurement here on the wire into this wireless base. Again, I have this meter measuring the voltage and this meter measuring the current. You can see it's drawing virtually no current, and it's currently at 5 volts. When I put the phone on the stand, it may take a second to recognize it, but then you can see we increase our current flow. We also increase our voltage when charging. And so again, we're going to check this every 15 minutes to record our voltage, our current, and then we're going to also record the phone battery percentage. And with these numbers, we're going to get an average power input into this charging base to charge the phone. And then over time, we're going to convert that to the amount of energy required into this system here to charge the phone.
On this slide, you can see the team's data for the phone plugged in directly. You can see that the team took the voltage and the current and checked back every 15 minutes on the percentage charged. And the team made sure to use a data point when comparing both of these phones from the same battery percentage. And so you will see on the next slide, but both phones charged at one data point to 72%, and this was used to calculate the total energy needed to get to that percent.
So similarly, this is the data that we collected for charging the phone on a wireless charger. Again, we checked in every 15 minutes. We recorded the voltage, current, and percentage of the phone.
On this slide, you can see the team calculate the total energy that would be needed to charge the battery to 72%. So the team first began by taking the manufacturer's battery capacity, and the team times it by 0.86 due to the battery health of the phone being at only 86% of what it originally was. And then the team times it by 0.72 to correlate that with the battery percentage and so the total energy within the phone. And the team's total energy needed to get the battery to 72% charge would be 22,656.5 joules.
So what we found, the average power to charge the phone to 72% was 4.88 watts when we plugged it in directly. And so we wanted to convert this to energy, or find the energy that it took to do this. So we took our power, we multiplied that by 1.75 hours, and then we converted it to seconds to give us energy in the units of joules. And so what we found was it took 30,751.3 joules of energy into the system to charge the phone with a wired connection. So to find the efficiency, we took the 27,656.5 joules of energy we found that went into the battery, and divided that by the total energy that we found into the system, which was again 30,751.3 joules. That gave us an efficiency of almost 90%.
On this slide, you can see the team's calculations for the wireless charger. The team found the average power across the 72% charge to be 8.09 watts. Note that this is higher than the power input for the wired charging method. And the team times it by 1.75 hours due to that's how much time it took to charge it. And the team calculated that the energy input into the system to charge the battery to 72% was 50,983.9 joules. And the team found the efficiency by dividing the battery's energy required to 72% divided by the total energy input for the wireless charger. And the team found this to be 54.25% efficiency.
So to determine which method is more or less efficient, we decided to do a relative efficiency calculation. To do this, we took the efficiency of plugging the phone directly in, subtracting it from the efficiency of charging the phone on a wireless base, and then dividing that by the efficiency of charging the phone on a wireless base. So you can see that we came out with that charging your phone on a wireless base is almost 40% less efficient than charging it directly plugging it into the phone.